This is video on kinematics of particles. This is the 14th video of the series, and here we are dealing with collision of particles. Now, this topic of collision of particles at times is viewed as part of kinetics of particles. At times it is viewed independently also. In any case, now you see we have chosen it to be part of the kinematics of particle. Now this video 4 is devoted to oblique collision with infinite mass. And just to refresh your memories, as explained in earlier videos in collision, these two governing equations. First equation is conservation of momentum, and second equation is velocity of separation upon velocity of approach is coefficient of restitution. These two get reduced to a single equation like this. Here we consider m2 as the infinite mass, and therefore because mass is infinite and final velocities of initial and final velocity of this infinite mass, like before collision and after collision, both are zero, and therefore these two equations get reduced to this one single equation. This part we have discussed in earlier videos. So for solving problem, we have now only one equation. Now let's look at a typical problem. It looks like this. It says a billiard ball moving 4 meters per second strikes a smooth plane at an angle of 35 degrees as shown in figure. See, this is 35 degrees, this is the billiard ball, and this is its velocity. Now, if coefficient of restitution is 0.6, what is the velocity with which the ball rebounds? So, ball comes like this. We want to know when it rebounds, what is its velocity. So, what we'll do is we'll call this ball as A, and it is having collision with this plane which has, in comparison with ball, infinite mass, and we'll call it as body B. Now, we'll treat this as x-axis, this is y-axis. Now, we realize that when the ball is here, when it touches this plane, the line of impact is y-axis. So, line of impact will be y-axis. There won't be any impact on x-axis, and based on this, we'll start writing the data systematically. So u1x means initial velocity of body 1 in x direction. I think we all can agree that it is 4 cos 35. And u2x, that is initial velocity of this plane, whether in x or y direction, is 0. Now u1y, that is initial velocity of body 1 in y direction, is 4 sin 35 in negative direction, so minus 4 sin 35. And u2y is 0. After all, this body has infinite mass, it doesn't move. Now, because we said that line of impact is y-axis, there is no impact in x-axis, along x-axis, and therefore initial velocity in x direction and final velocity in x direction will be same, and therefore v1x we have written as 4 cos 35, same as u1x. v2x is again 0. Now, as far as v2y is concerned, v1y is concerned, v1y, we write it as e into u1y, and the reason is this equation we are using. The final velocity is coefficient of restitution into initial velocity. So, initial velocity in y direction is this, 4 sin 35. So, final velocity of body 1 in y direction is 0.64 sin 35. And v2y is 0. Final velocity in y direction of body 2 is also 0. So, finally what we are left with is v1x and v1y. So, we can find square at take under root, we can find the magnitude, and we can also find the direction, that is tan inverse of v1y by v1x. So, it is with this velocity 3.55 meter per second at an angle of 22.8 degree, the ball will rebounce, the ball will rebounce, and that is what was asked. Thank you.